Hello, guys.
Hey,
Hello.
everyone made it back okay?
In one piece.
Great. I don't think Ying will join us today. So let's wait for. And Jinpeng is on the long leave. Oh, Ying made it today. Great. Let's wait for a couple of minutes. Let me ping her over IM over WeChat. Okay. So we have a fulcrum here. Last week, I think I was attending the Civilcon, and Will James PR to integrate into Crimson, and I will be working on the performance test working on integrating the performance test into our continuation integration. And I will ping Alfredo probably to work with him to get it done. That's me. May.
What kind of performance integration you will do?
The plan is to add a test, just like what we have in existing CI. In existing CI, we have multiple tests. For example, to check if the doc build and to check if there are any unintended submodule changes, and to check the sign of by lines added to the commit message. But in addition to it, I think we need to check the possible performance degradation introduced by the PR in question. For example, if the PR is labeled with crimson and the PR hurts the performance in a significant way, we should vote down the PR. That's the idea.
So that is automatically testing, performance testing, right?
Yes.
When we provide the PR, and it will be automatically tested.
Yes.
Okay, so last 2 weeks I'm working on the remote server Kubernetes OSD test. I have sent out the test result. For the locally, just one host, and if I use default options, that means the async thread will be default set to be 3, and For the SSD, OSD shard will be set to 8, and threads per shard will be set to. At this default options, and on the locally means on one host, Ceph OSD is better than Crimson OSD for the latency and IOPS. And if I cite, even though I pin the Ceph OSD process to one core, it is still better than Crimson OSD. And when I set the out thread setting to be 1, and Crimson OSD is better than Ceph OSD. That is on the one host. If across the server, I use two servers, and I set the Ceph OSD threads to be 1, all the threads to be 1, and Crimson OSD it get the similar performance as the Ceph OSD. So I check Jianpeng's before messenger test. So when the client side is set, it's used Crimson, it's used async messenger. Just for the messenger layer test, if the client side is used async messenger, and in most cases, async to async is better than async to Crimson. So I think that may be the reason why the Ceph OSD Crimson OSD get the similar performance as the Ceph OSD across the server.
When you said you set the threads to 1, did you set? So you would have set the async messenger thread pool, whatever, to 1, and also the op thread pool to 1. Is that accurate?
Yeah, async messenger SMP set to 1. Just run one thread for Crimson OSD.
Right. I'm saying for classic OSD. How did you actually set it to 1 thread?
Yeah, I set async thread to be 1, OSD thread to be 1, shard to be 1.
Right. So that's not enough because all of those would run on different cores, probably. So you actually need to use thread affinity to force all of those threads onto one core.
Yeah, I also force it to be on the one core.
How?
I use the task site
Okay,
to
cool.
set the process to be to run on the core 0.
Okay, good. That's right then. So you're saying under that configuration with the client on server A and the OSD on server B,
yes,
but just one server for the for the OSD, that is.
Yeah,
just one OSD
on the one server.
So in that scenario, you found that they were pretty similar?
Yeah.
Okay.
Pretty similar. So I have sent out. I think I have sent out to most of you.
Did you successfully saturate the OSD?
Saturate.
In other words, did the CPU did in both cases was the CPU completely pegged?
CPU.
What was the CPU usage by then?
Was it at 100% or was it at less than 100%?
I didn't check it. I just get the perf status.
Yeah, so if it's latency bound and you're limited by the latency of the network, then it's probable that the throughput was entirely determined by the network latency between the two servers. So within reason, you wouldn't.
It's 10G networking.
It's not throughput.
I use Rados bench. It's only about 15 and 16 concurrency.
Right, that may not have been enough. It's not 10G means it has high throughput, but it still has finite latency, right? So 15 single-threaded reads, yeah, that wouldn't be enough. You'd have to, if it had a millisecond of latency, that would be like 80 microseconds, which might be too long, actually.
Okay.
Do I have that right? Did I do the math right?
So you mean the 10G networking introduce the most latency?
It's just that the latency is dominated by the networking. Possibly. This is just a guess.
Yeah. So yeah.
In which case
the
you wanted
latency
to
getting bigger.
In which case, what you wanted to do was turn the thread option on Rados bench up until the CPU core was saturated and the latency looked really bad. Like
I don't think the CPU saturated because it's only
yeah,
15.
So what I'm
Yeah.
saying is the only metric we care about for Crimson is ops per CPU cycle, right? So what you want to do is you want to take Rados Bench, and we're testing throughput here. So you want to take the -T option and turn it up to be big enough that the latency is awful. Just bad, right? That proves that you fully saturated the OSD side, and then whatever throughput number you're getting is like the best that that server can possibly do with that code path. That will wash out the latency from the network. Now, if you're interested in latency, that's a different test. But I think for our purposes for now, we're primarily interested in CPU efficiency. So my suggestion is that you take the Rados bench command you were using, and instead of -T equals 16, try -T equals 256, and then take a look at the latency. It should be pretty high. Quite a bit, maybe at least twice as high as whatever you measured in this test. Possibly
I increased
the
concurrency to 100.
Oh, okay. So what happened when you did that?
And so for the it is the latency is increased.
Yeah, so that's good. The question is, what happened to the throughput?
7 times, maybe over 7 times the latency, but the difference between the Ceph OSD and the Crimson OSD is about less than 1 milliseconds.
No, we're not interested in latency.
I think less than 1 microsecond.
We're interested in the throughput. When you get it, or so when you increase the thread count or the number of concurrent requests to 100, throughput remained about the same?
LPS, you mean?
Yeah.
Similar. One is 612. One is 2630.
Yeah, so it's exactly the same. It might be limited by the client side, actually. Did you check the did you check the you said the latency went up by like a factor of 7, right?
Pardon?
You said the latency went up by a factor of 7?
When I use default, it's 15, 16 concurrency. If I set it to be 100, it is about 7 times.
Okay, so it's probably saturated. That's probably that's likely good enough. Unless the client side was saturated. Radek, I think you said that you needed to run 2 Rados benches to get it to actually saturate.
Correct, but this was on Incerta. On read tests, I'm seeing there are around 25,000 thousands of IOPS.
In what test case, 25,000 IOPS?
In Certa, but that's with 2 different clients. You might be saturated on the client side. So the Rados bench isn't super efficient, and librados definitely isn't. Because if you think about it, we've only crimsoned the server side. We haven't crimsoned the client side. You might need to run 2 different Rados bench instances to actually properly saturate the server. It's possible that what you actually saturated there is the client side objector.
So what the client side?
The Rados bench command you're using itself is actually very complicated. It has a full libretto stack, and it's not super efficient. You might need to run 2 of them.
Oh, run 2. You mean run 2 Rados bench test?
Yeah, unless you work at. Yeah, exactly, and then sum the IOPS. I'm not sure, but I think Radek had to do that to get it to actually saturate. Basically, the client is slower than the server.
Just posted a link to GIST with one of my tests.
And Kefu, I need to discuss with you offline about my next task.
Sure, we can do it after the meeting if you like.
Yeah, okay.
Sure.
So that's all from me.
Okay, right there.
First of sorry. First of all, some reviews. Still, I posted some comments to Sam's peering stuff. Still, the review is a work in progress. However, I'm yesterday and this week I was focused mostly on drilling down through the DPDK implementation and DPDK-based implementation of SeaStor's networking stack, and I guess I know what's the reason why the interfaces for reading from SeaStor's socket have been designed in that way. Well, this is widely interconnected with our problems with specifying alignment, with the extra mem copy from user space to user space we are having during write serving. And basically, I'm under impression that the design is a compromise to handle DPDK stack effectively without any zero copy. Let's imagine that how a flow of Ethernet frame looks like from DPDK point of view. Basically, the network card is instructed where the buffer is placed, and the DMA puts data there. Data means Ethernet frames, possibly a lot of them. And those frames are processed. This can be seen, I imagine this personally just as basically as some kind of pointer operations where we are squeezing headers, and when we are squeezing headers just to take a payload. However, payload, there is, in case of DPDK, this payload can be transferred directly to application using a scatter-gather list, because it's very likely it will be fragmented because of how the protocol, how Ethernet protocol is designed. It's because frames are pretty small. Even jumbo frames are up to 9K. Usual frame is just around 1,500 bytes. So they are fragmented by design. And to handle it, application really needs to use scatter-gather list. If it don't want memcopy, of course. However, when it comes to kernel, we have some extra requirements, like the isolation between kernel memory and user application memory. So this boils down to the fact that basically, in case of fragmented frames, kernel really needs to do memcopy, and that's the reason why when you are reading a payload, a network payload from kernel, you can specify your buffer, location of your buffer, but that's not the case of SeaStor. SeaStor that's not the case of DPDK in SeaStor. In there you all are doing is asking the stack for payload. You don't provide a location of buffer. Stack gives it you for it. You don't control also the length. It's up to stack. And well, to handle I believe we will need to handle both DPDK and POSIX stacks effectively. So quite likely we will need to introduce some kind of extension to SeaStor, and also verify whether our entire IO path is able to effectively use scatter-gather list. I think the second is not a big problem, because basically, well, we are using everywhere buffer list. So modifications at our site would be just to not enforce SeaStor to read into one single contiguous buffer, which in case of DPDK will enforce memory copy, unnecessary memory copy. But in case of kernel, well, as the memory copy is basically obligatory because for the sake of isolation, well, we also want to be able to specify alignment. I'm sketching some interface extensions. Basically, we would need something like allocator, but not in the sense of things like polymorphic, like C++ allocator, when the user, the client of the allocator, is responsible for specify the size he wants to allocate. We will need to have the size under control of allocator itself. And well, in case of POSIX stacks, the concept of allocator is actually there, but it's not enough because SeaStor is responsible for specifying the size, which is just buff size, and that by default equals to 8K. I also reviewed Yingxin. I also reviewed your read exactly 2 proposal, and it will play. I'm pretty sure it will play. It could play nicely with POSIX after reduction and then of the number of read syscalls we have per message. However, it might enforce a copy in the case of DPDK networking.
And another issue is that it will have more system calls.
Yes, but we can minimize that. Basically, on average, I believe we could go with one single read operation, one read syscall per message, on average. This would require some hack. Basically, first of all, you always need to issue a syscall for reading the prologue of first V2 frame. But then, after getting it, you could issue a read, not only for the entire first frame. You could also instruct ask kernel for the data for next frame prologue. On average, that would give you one syscall per frame.
Radek, can you repeat why do we have to make 2 read calls for V2 frame? We can read a large amount. We can ask for a large amount of data, which will include a header and more than the reasonable size of a buffer, and then just get what there is. Maybe with the second header there also.
Well, that's I'm talking about. We can predict. Well, at the moment, the buff size is constant and set by SeaStor. If Crimson will be able to instruct to tune the size of the reading chunk dynamically, we could do that.
Do we have to have it dynamically? We can just over allocate, use very large buffers, which are more than most of our interactions, and just waste a bit of.
Yes, but we also need to take care about the alignment in the case of POSIX stack.
Okay, but the header is aligned. This buffer will be aligned.
We need to alignment for header is not so important. We have in current implementation of protocol V2 a data segment being basically put in the middle of the V2 frame needs to be aligned.
But is it already aligned if you take, for example, if you align the beginning of the whole message, the beginning of the header, everything inside is already aligned?
No, it's aligned to, we need to align to 4K. It will be aligned to 16 bytes by default. In your case, it will be aligned to size of AES block size, and I'm pretty sure it's only when you are doing the on-wire encryption. In plain, well, definitely it won't be aligned to 4K. We need to take special care for that.
Okay. Okay.
Riddle, I think we can discuss offline to understand your idea.
Sure.
Okay.
Yeah, we need to had a proposal regarding to the interface based on your change.
Excuse me, we have. I'm getting network glitches. Could you please repeat?
Sure. I'm echoing. I was echoing with echoing Yinxin's proposal. We need to come up with a proposal based on your change you posted in the chat just now, and send it over.
Well, I'm not sure whether it's reasonable or not. We need to discuss.
Sure, that's the point. We need to discuss just physically based on your change to come up with a better idea what we need and what we have and what we want. And so Riddle, what's your next step?
Let's schedule a call.
Sure. We can do it after the meeting.
Okay.
I would prefer if we can do it not now. I have a course that starts now for a few hours. From 9 o'clock, I'm busy. From the end of this hour, I'm busy. So we can postpone
I will
it.
Probably 1 hour after now. I will send an invitation anyway.
Okay, I'm fine. I'm fine with having the call later.
Sure. And Ronan.
Yeah. Hi. Not much new for me. You know where I was. I have a question. Fedora 30. Have you installed it? I had a problem with libibcm, which was part of the. I think I installed it for the compilation of. Sorry, here's the video again.
Could you
post
the error message? Could you paste it somewhere?
Yeah. 1 second.
We can check it out.
I might have had to add my laptop has Fedora 30. I had to add an additional library or something, but more importantly, somewhere down in DPDK, I had to add a suppression for an error.
Can you?
Which one it is?
I'm 1 second. I'm posting it now, and tell me what.
Oh no, that's a whole separate thing. I'm not sure what that is.
No. Where is it? Okay, here is it. A package libibcm requires RDMA core, but none of the providers can be installed. RDMA core. I noted it's not I'm the only one suffering for this. Something changed in the libraries provided by RDMA core.
Oh, you're trying to do an actual upgrade.
Yes.
My suggestion is that you uninstall all the libraries that are giving you trouble, do the upgrade, and then try and fix it. You're asking a lot of DNF.
Okay. You don't. There won't be a problem compiling Ceph after the upgrade.
I had one
It didn't
stupid problem because GCC added a new thing as a default error
Mm-hmm.
to dash wall. I'll email you the or whatever. I'll email you the diff in DPDK that I had to apply to the CMake list to suppress it.
Okay.
Um,
Thanks.
but other than it, like it tells you what the error is. It's the usual thing. You just have to add with no whatever the error name is. I'll send it to you.
Okay. Okay. Good. Thanks. Other than that, not much from my side. I was in a new hire orientation.
Okay, by the way, Ronan, next time you paste the error message, probably you can use a service like pastebin, so the message are not cluttered.
Okay. Good. Thanks.
Thank you. Understand.
Yep. I addressed at least the first batch of comments on the PR. A few of them I didn't agree with. I commented on. So if you still disagree.
Sure, I will try to review it again today.
Yep, or whatever. So I'm working on the op thing. I think it's boiled down to two things. One, every op of each type should be on a linked list that can be dumped cheaply. From that is when we start an op, be it a peering op or a client op or a backfill op or whatever, it should be in a shard wide like linked list. So you can walk the list and dump all of the currently in progress operations. And secondly, whenever an operation is not currently making progress, it will have a pointer to a blocker, which can be dumped in a way that gives you useful information for whatever that means for that blocker. For if it's waiting on OSD map, it'll say blocker waiting on OSD map 30. Like, there's not a lot to it, but I think that's the right way to go. Secondarily, the actual problem that I'm trying to figure out is if we accept 5 IOs from the same connection and we do the thing we're currently doing where we just fork off a future for each one, we have a problem because we don't actually have a guarantee of deterministic execution. So if we got 3 IOs or 3 writes, let's say, on the same object from the same client, and we read them off the wire one after another, I believe the way the dispatcher currently works is that it will just let the future for each of those run independently, and then it'll immediately go back to grab the next one. In practice, obviously, the core is only doing one of these things, and most of the time, the thing we started doing will continue running until it stops, but that's not actually a guarantee. SeaStor doesn't guarantee that. I think there's a default after 127 future returns, it'll switch to something else or something, and there's a way to like ask it to preempt between future calls. I think if you like wake up a promise in like urgent mode, it will cause the currently running execution to stop and the other thing will run instead. Which is to say that I think what we have to do is we have to run, that is the future return from the dispatch should itself fork the first time it hits a blocker. So let's say we're doing a client write. When the op comes in from the dispatcher, the MS dispatch call that returns a future, that future should continue blocking until it hits either a queue or waiting for OSD map or something that guarantees ordering, and that should always be the rule. So I don't.
Sam, if I understand correctly, your suggestion is that the dispatch message should be blocked.
Exactly. Until that handler says, okay, it's okay to do something. I've taken care of the ordering part now. It's annoying because it's more difficult to program that way, but I think we have to do it that way. Otherwise, we'll have actual, like, non-deterministic behavior. It'll be super hard to debug. That's what I'm actually thinking about. I may not solve that with this PR, but I don't know. We'll see.
Yeah, I thought I have one version of that implementation to block messenger to dispatch and wait for the future of the MS dispatch.
That's the messenger side, and that's just what I think it should do. The dispatch the dispatch contract should be that the future return from dispatch should represent the operation should represent the point at which that connection can go back to doing other work. If that makes sense. So it doesn't have to represent the entire message processing loop. It just has to represent that part up to the point at which it's safe to read something else off the wire.
But the order that a message thrown into reactor, it is like FIFOQ, right? So it is also ordered.
It's not. No. So generally speaking, you might read, so the way it's currently implemented, you'll read, correct me if I'm wrong, I could easily be misunderstanding. But if you read 5 writes off the wire from the same writer, and let's say for whatever reason, one of them blocks and stops executing, and the other 4 are able to continue, those 4 will definitely run to completion while the third one, let's say, is stopped, right? But it's worse. If all 5 of them don't block, but they have really long future chains, or something preempts, that is, something in the reactor wants to run earlier, then the execution of any of them can be stopped. The reactor can pick something else off of its pile of currently running futures, run that, and then there's no guarantee as to which one it picks up next.
Okay.
It's like different threads. There's no guarantee in the Linux kernel as to which thread will be scheduled next. There are heuristics and rules about like likelihood and share of CPU, but nothing that guarantees that threads run in the order in which they respond.
Yeah, you mean if the first message is blocked, the second message
can still for example, be the first message takes five steps to complete, and this block like third step, and the second message is very lucky, and it has it composed only 2 steps and complete faster than the first message.
Or worse, they're both 5 steps, but one of the things that the first message did is unblock another task, and that task got unblocked urgently. Even if it isn't actually blocked, the reactor may choose to drop the the task that's currently executing and pick up the one that just got unblocked. There's no determinism.
So we only care about the sequence in same PG.
No, we only care about the ones in the same object, on the same connection, actually. So it's even more specific.
Not same connection, same PG. H maybe go to the different PG.
No, I'm saying. So well, that's true too. But what I'm saying is on the tuple of PG or of a connection and object. So if either of those is different, we don't care about the order. It's just that for convenience sake, typically you wait on the connection PG tuple first, and then the connection object tuple after you've been dispatched to a PG. So anywhere you block on that chain, it may change slightly what the tuple is. But the important thing is that you can't just start another task until the first one has either blocked or completed. And the rules of blocking are really important because like the way we do the blocking needs to guarantee that when we pick it back up, we pick up the first one that blocked, not the second one. I didn't see anything obviously in SeaStor to handle this, which doesn't really surprise me because it's kind of application specific. And usually you design things so that this isn't necessary in the first place.
But Sam, what if the message does not have any side effect? For example, the first message,
My guess is you'd write the handler so that it does what the messenger currently does. Like you're still free to write the handler so that it does what the messenger currently does. It's just that if you don't write the messenger that way, you have the freedom to say, actually, hold up, I need you to wait. Wait until I've gotten at least this far, and now you can go ahead and read a new one, right?
Okay. Put it another way, if it's an operation had no side effect, we can just dispatch it to anything.
Like OSD maps are always going to be kind of like that, right? Although maybe not. Maybe we actually don't even want to do that. Maybe we always want to run those to completion because they block so many other things. It's unclear. We'll have to think about it. But yeah, it's not that we can't ever fork off a new task. I think that the way SeaStor's reactor works, I don't think it's even expensive to have a lot of tasks ready to run the reactor. It's just that when we care about ordering, we have to be careful about when we have multiple runnable tasks because the reactor can choose all of them. Really, I think. Yeah.
So in the original Ceph OSD messenger layer, they use the sequence number to guarantee the sequence.
No, it uses a series of queues. The sequence number is convenient, and it lets you tell if the queue's messed up, but in principle, if you just like scrub the number out, it would still work. What's actually going on is that a single thread in a loop reads one message at a time, and every message that gets read gets put into a first in, first out queue, right? Then the op thread picks it out of the first in, first out queue, does its thing, which for a read is the whole operation. Eventually, it'll call that in a file store block on a kernel IO thing, pick back up, return, and then tell the messenger to send it back out, wherein it goes into yet another first in, first out queue, where the sender thread picks it up and sends it. So it's a sequence of threads which are preempted by the kernel, but not within the thread, if you take my meaning, connected by first in, first out queues. And it's super brittle. Does that make sense?
So you talk about only the messenger layer?
No, I just described the whole read pathway, actually.
Okay. So I just heard that you mentioned the messenger layer to need to guarantee the sequence.
So what happens is the messenger layer reads off of the wire in a loop, right? But every time it completes the reading of a message, it places it into a first in, first out queue.
So different layer use different layer use different mechanism to guarantee the sequence in one PG.
It's pretty much the same mechanism all the way through. It's just like standard lists with atomics around them.
Yeah. So the messenger layer uses the sequence number, and the OSD layer uses the PG lock.
So it has a sequence number, but it doesn't really use it. Not for this anyway.
Yeah, it's not for use. It's not for this purpose.
Yeah. For instance, like even at the network layer, TCP already has that, right? You're reading an ordered stream of bytes. Like the header tells you how many bytes you're going to read. You read those bytes, then you decode them into a message, stick it onto a queue, and then another thread will pick it up and do its thing, and then stick the result of that onto yet another queue, and so on. As long as that ordering always stays the same, the messages will always build up in the intermediate queues and get processed in order. But with Crimson, it's a little weirder because our threads are actually the task structures. So it's a little bit like we're spawning a thread for every request, which is fine as long as there are no ordering requirements between the requests. But for us, we kind of do have them. So we have to do enough of the processing to be sure that the next one won't hop over us. Yeah, that's as far as I've kind of gotten thinking about it. Correct me if I'm wrong about SeaStor though. Like, is there a mechanism that I'm missing? Like, it's a little bit like an execution stage, I suppose, but we need a little more than what execution stage provides. So I suspect that won't be enough.
I didn't see anything for this purpose in the documents in SeaStor.
Yeah. That's okay. Like, we don't really expect to find that there, and we're going to have some pretty specific like things we want from the queues, like the ability to introspect them and to find out why they're blocking in the first place. So it's probably fine. And it's not like complicated, right? At least hopefully not.
Sam?
Yeah.
Could waiting, proper waiting on, let's say, object state handle the issue?
That's what we're doing. That's what I'm describing. We need a way to do that maintains this ordering correctly, is not incredibly annoying to code to like work with. And finally, if let's say some particular object, probably a Rados GW bucket, is causing trouble and causing blocked requests, I want to be able to dump the requests on the OSD and find out which object it is and why it's blocked. So that's kind of like, that's why my architecture is like, but the structure is like all ops are on a queue for their whole lifetime. And while they are not making progress, they must also point at the thing that's stopping them. And furthermore, the thing that's stopping them probably is like logically a task that's runnable and maintains the ordering of the things that are stuck in it. I think that's kind of how it has to work.
Sounds reasonable.
Yeah. Okay.
Samuel, can you please write down a document for the discussion?
Oh, I'll have a PR for it once it's a little more baked. I got it pretty well baked on the plane on Friday.
Can you send the link here?
Well, it doesn't work yet. I wanted another day or two, and then I'll send a PR with like an explanation.
Okay.
I got it pretty well baked on the plane on the way back on Friday, but I have more to work through. I don't, for instance, have the part where it maintains ordering. I don't have a good primitive for that yet.
Yeah, I agree with you. We need some mechanisms to guarantee the sequence.
Yeah, I mean the mechanisms are in SeaStor, right? We just need we need a convention for how to do it, so that we all kind of like look at the code and go, oh, it's maintaining the ordering. Okay.
So you prefer
No
use
problem.
some user space queues?
Well, I mean, we're definitely using user space queues, right? We made that choice when we decided to go with SeaStor, insofar as we have decided to go with SeaStor. One thread means no kernel scheduling, right? We have to do our scheduling in user space. And we'll use SeaStar scheduling insofar as a task equals a thread. So all we really need is like kind of like a mutex, I guess, but with more stuff.
So SeaStar provide a mutex.
It does, but it doesn't provide the other stuff. It doesn't provide the thing where when we wake them up, they need to be woken up in order, and each one needs to finish that stage before the next one gets woken up. And I don't know what that means yet. You know what I mean? Like let's say we wake something up from an object state stop. So if the next thing it needs to do is do a read, it needs to finish that read before we wake up the writer that's waiting behind it, for obvious reasons, right? If it gets stopped partway through the read, it would be bad if a writer woke up, wrote to the state it's reading, and then completed, and then the reader wakes up and goes, oh, my stuff got written too.
So when you use SeaStar mutex, it will guarantee the sequence, right?
Sort of.
Mutex,
oh, well, in that sense, yes, but it's okay. So mutex is a bad example because when the read wakes up, it will immediately take the mutex. A better example is an OSD map gate, where we're waiting for OSD map 20 to show up. Logically, when that happens, every op that was waiting gets woken up, right?
So if we block if the task block on the same situation, same condition, so when the SeaStar fulfill the promise, the SeaStar cannot guarantee the FIFO.
What's going to happen is it's going to wake up all the tasks, and it'll be a free for all.
For example, they're waking up for the OSD map.
Yeah,
so
it's going to wake up all the tasks.
SeaStar framework will invoke the first block one, or they couldn't guarantee the sequence.
I don't even know if invoking a promise is actually ordered at all. It might be totally non-deterministic. But even if it is, that's not strong enough.
So it guarantees the sequence.
It's not strong enough though. That's what I'm saying. Even if it is ordered.
Yes, it's ordered, but I think the thing we could be worried is that it's not a contract building explained in the SeaStar interface, but
even
by
if it were,
implementation, the order the task is queued in the FIFO, first in come first served manner.
Yeah, but so even if that's true, and I think you're right, I think it is. It's not strong enough because it may be the case that the first one is preempted or for whatever reason stops executing. And then you have no guarantee that one gets picked up later because now we're not talking about a mutex, we're just talking about the order in which the reactor picks up runnable tasks.
So you mean for this condition, for the any condition is not meet, we need to wait some condition satisfied. We need a user space queue, right?
Yeah, what we actually need is we need a way for the first thing that gets woken up to signal that it's okay for the next thing to get woken up, which will either be it's done or it's blocked. I think that's how it has to work.
Currently, the existing self-OSD for this condition, they use a user space queue. If some condition not meet, and they include the request when the condition is.
The word queue is tough here because, in the case of the classic OSD, we mean literally like a standard list with a mutex around it, right? It's a producer-consumer queue for connecting two different threads. Here, we have something a little bit more like the kernel's waitlist. And the problem is when you wake up the stuff on a waitlist, it's now non-deterministic the order in which they run. That's the problem we have. So what we actually need to do is something a little more subtle than just waking everything up. We have to wake the first thing up and then wait until it says that it's okay for the next thing to wake up. Which will either be it's completed or it's blocked at the next stage. I think. At least that's my guess. Because the problem isn't it's that at the level of the reactor, the reactor doesn't really know the difference between I'm runnable, or I'm like, it doesn't really know the difference between I'm blocked, but it's okay to wake someone else up. That's like the next thing in that mutex that I got woken up for like way in the past. It doesn't know the difference between that and I'm stopped, but it's actually still not okay to wake someone up because it might change the ordering. Which is fine. It just means we have to encode that rule into the primitive we use for blocking. It's fine.
So in a way, we are using a second mechanism on top of what SeaStor is using, which
SeaStor,
it doesn't give a good feeling.
What SeaStor gives us is a few basic primitives, and to be clear, we'll be using promises and futures, right? We are using the SeaStor primitives. We're just using something to impose a little bit more order than SeaStor gives us by default. It's no different from creating a user space, like a producer-consumer queue on top of threads.
So if we use the user queue to guarantee the sequence, we needn't use the future promise.
Well, you kind of do because that's the natural way to communicate with the SeaStor reactor.
Yes.
But when we use that future and the promise, we involve the SeaStor framework and we involve the SeaStor code scheduler.
Yeah,
so
that's right. That's the
scheduler, user space, our user space schedule.
SeaStor is the user space scheduler I'm talking about. The primitive you use to communicate with it is promises and futures. What we're doing is not like creating a scheduler. It's using a scheduler as one would if one were creating a producer-consumer queue with p-threads. It's no different, right? You communicate with the kernel saying, okay, I need you to wake the consumer up when you put something onto the queue. And the scheduler goes and does its thing. It wakes the consumer up. Consumer goes, oh, there's something in the queue. And then it goes and does its thing. Same kind of deal.
Yeah, we could use the future to indicate the intention of the task to see if it wanted to hand over the thread to another or control to another. If it have no side effect, it just can return SeaStor now. Or just return nothing.
Yeah.
To run itself in an async way.
Yeah, I think that's kind of what has to happen.
So basically, it's a different kind. If we would have wrapped it inside SeaStor, it would have been some kind of alternate then with an added condition, added promise to wait for?
It would be like a more complicated thing in future util, which, I mean, we could add, right? If it turns out to be reasonably general, maybe they want it. But there's a lot of stuff like this in SeaStor, right? It's just that they don't have this specific thing. Like they have a lot of little thingies built on top of futures and promises. If you go look at shared promise and shared future, same deal, right? Or they have a stream mechanism, which is exactly the same thing. It's not quite powerful enough for this, annoyingly, but it's close.
Yes, there are a lot of utilities built on future and the promises in SeaStor, but they are not able to be used.
I mean, that makes sense, right? User applications built on top of SeaStor are going to be pretty specific about what they want, so it doesn't make a great deal of sense to write like really specific things and add them to the library unless you're pretty sure they'll have a lot of users.
Well, sequencing like this might be a general enough.
It could be, but it's going to be pretty closely tied into the way we think about ops. So maybe not. Could be. We'll see. I expect that when I submit the PR, there will be opinions and it will be rewritten. I haven't done that much C++ lately, so it's unlikely that I'll come up with the best answer. But maybe something.
Yeah, I think I would imagine the way we include a new task just to change the condition to the existing continuation queue. That would suffice.
It's just that I worry. I think if we do that, they get woken non-deterministically. That's the problem. Like if 5 ops show up and I'll wait on the promise that represents OSD map epoch 15, then when they're woken up, they will usually execute an order, but it's not a guarantee. It's an accident, I think.
So I have to leave the meeting.
Yes, sorry.
Yeah, sorry about that. That went too long.
Later on, I will send an invitation in 1 hour also. We discuss the alien thing.
If you,
Thing, sorry.
Okay, I hope I'll be able to make it. I'm busy. I'm in a meeting from now until this evening, so I'm available during noon today.
Okay.
Or if you're doing
in 1 hour, how about in 1 hour?
1 hour, 1 hour,
Yeah.
I won't be able to.
After this,
okay.
2 hours. Okay.
No, what I'm saying is I'm now starting a course until this afternoon. So
okay.
As you go ahead and do the meeting now if you want to. I'll see a recording if they'll be available. Okay, if you can record it. Or if you want to postpone it to tomorrow, same hour, it will be better.
Ridek and Ying, what do you think?
I'm fine with all options here. However, if you want to do it now, I would prefer to have maybe 1 hour and a half just to relocate to the office. However, tomorrow is also fine. So up to you.
I'm okay with both.
How about tomorrow same time? Ronan, what do you think?
That's good.
Okay. I'll send the
I would
invitation.
love that. Okay, good. Thank you very much for accommodating me this time. Thank you. Bye.
No worry, no problem. And Yingxin?
Yeah, I will just come back today, and so nothing pretty much new for me. And I will work on the alignment and length requirement interface. That's all.
And Yingxin, could you stay a little bit longer so we can discuss the task for Chunmei? I think pretty much of the task will be falling to the category of messenger after this meeting.
I think currently we are only discuss the alignment, right?
I'm talking about the possible task for Chunmei because it will be on a long leave.
I think we already listed them in the project.
Okay.
Right.
Okay. So
do we
any of them
now?
We can do it now. After this meeting.
Okay.
Right after this meeting. It will be very short. Just to list some things that would be interesting to me, but not very urgent ones.
Okay.
Any questions, guys?
Yep. It's good seeing all you guys.
Me too. Talk guys later.
Yep.
Cool. Thanks for the meeting. See you.
See you.
Bye.
And
do we create another new link?
Sure, I will post my the link in the URL.
In the chat.
Oh, sorry, in the chat window. Sure. Hold on. Let's switch over to this meeting room. Talk to you guys later.